Hi, welcome to Mat100. Today we're going to talk about section 10.3, which is solving right triangles. And this is very useful, but sometimes it's kind of difficult when you're first starting out. But it's kind of practical too. It's a kind of a practical application. So remember that we have 6 relationships, but basically 3 that we use because of our computer or our calculator. We have the sine, cosine, and the tangent. So let me put those down. The sine of an angle, let's call it angle x, is equal to the opposite side over the hypotenuse. Remember, the hypotenuse is always the longest side. The cosine of x is equal to the adjacent side over the hypotenuse. And we'll be using this quite often. And then, of course, the tangent of x is equal to the opposite side over the adjacent side. And then we'll show you how we're going to use this to help us solve triangles. Okay. The advantage to trigonometry over geometry works for special angles, 30-degree angles and so on, but this will work for any angle. The first thing we want to make sure, though, is on this particular calculator that I had recommended, you want to go to something called degrees, DRG. You want to hit that key. Well, first we want to turn on the calculator, huh? But we want to hit that key and make sure that the word degree is underlined, not radian or gradian. That it's underlined. And if it is underlined, let's say it wasn't, it was on radian, well, then use your arrow keys to move back. And once it's back, hit your equal sign, hit your enter. And now it's set, and you can go back and check it. Now it's set to degrees. Okay, and I hit equal again to make sure. So once it's in degrees, because if you're in the wrong thing, it's not going to give you the correct answer. I'm going to set this off to the side and then pull it down as I need it. I'm going to look at a triangle here. Just make a quick sketch of it. And this is out of the book. This is angle B. Remember, we use angles, use capital letters, and sides use lowercase. So we have side A. Then if this is capital B, this would be side B. It's always opposite. This is your right angle, so that's always side C. And opposite that is always the hypotenuse. And this must be angle A. So this is angle A, B, C. This is side A, side B, side C. On this one, they told us this angle was 50 degrees, and they told us this was 21 centimeters. And what they want us to do on this particular problem, let's see, what do they want? Example 1, what are we trying to find here? I think we're trying to find side A. I didn't really see it in the instructions. Yeah, suppose we need to find side A. So we're trying to find side A. Okay, so this is where this information comes in handy. Side A, if we're looking, the only thing we know is angle B, so we have to reference it to the angle we know, angle B. So referencing that, this side becomes the opposite of B. This side we know is the hypotenuse, it's the longest side. Usually I find those two sides first, then this has to be the adjacent. So A, we know, well, let's put down what we know. We know angle B, but as far as the sides are concerned, we know the adjacent. We're trying to find the adjacent, I should say, and we know the hypotenuse. So we need a relationship that involves the adjacent and the hypotenuse. The only one we have here is cosine. Cosine involves the adjacent and the hypotenuse. So we're going to say the cosine of 50 degrees is equal to what? The adjacent A, which we don't know, over the hypotenuse, which we do know, 21. So we're using this one right here, adjacent over hypotenuse, A over 21. B would be the opposite, so we need the adjacent and we need the hypotenuse. Okay, now to solve this, this is a proportion, so we're going to cross multiply. A is equal to, let's put the A over here, it's equal to the cosine of 50 times 21. So on our calculator, we can go to the calculator, make sure it's cleared out. It's going to be the cosine. We're going to hit cosine, put in the spot that you can see, 50, and we know it's set to degrees. Put that in parentheses, times 21. Just that easy. And this should give us, being our answer, 13.49. Now, if we wanted that as a whole number, because this was a whole number, then this number behind it is a 4, and that's pretty small. So we're going to keep this at 13. So A is 13 centimeters. And there we have found this missing side. All right, let's try another one. Maybe another sheet of paper. Okay. Here we have another drawing, another angle. This time they're calling this A. This would still have to be C because this is your right angle. The right angle is always angle C, so this would have to be B. This is little c, and this is the hypotenuse. I'm going to abbreviate HYP, hypotenuse. And it says, and we know this is 71 degrees. What would this side be? This would be A. This would be B. Okay, so we got the drawing labeled. And we also know that this is 10. So it says find the length of the hypotenuse C. We're looking for C. We have an angle, but let's see, we're looking at basically the relationship of the sides. This side right here would be what? Opposite angle A. And this side would be adjacent. The bottom isn't always adjacent. It just matters how we drew it. So this is opposite. We're looking opposite this angle. So now we're trying to find C. So we need a relationship that involves the hypotenuse and the opposite because we know that. So if you look at our relationships here, the sine involves the opposite and the hypotenuse. So sine A equals the opposite over the hypotenuse. I write down the goodie here. So how can we find that? Well, the sine of A, which is 71 degrees, is equal to the side that's opposite, which is, I don't know if they gave a measurement here, inches, 10 inches. We won't write that down, but we'll put that here, over the hypotenuse, which we're going to call C. So now we've got the problem set up. Every problem is written a little different because it depends on what side we're trying to find what the relationship here. Here we use, on the first one, we use the cosine function, which is the adjacent over the hypotenuse. Because we knew the adjacent side, or we're trying to find the adjacent side. On this one, we needed a relationship involving opposite and hypotenuse. So we got it. Unfortunately, remember on this problem, we could just cross multiply. So what do we do here? Well, it's very simple. We can interchange these. We can say C is equal to 10 times. If we can't multiply them, we can switch them. Sine 71. So the C comes up on top, the sine goes on the bottom. They're interchangeable. Kind of weird, huh? So now we can find the answer by taking 10 and dividing it by the sine. We're going to hit sine key right there of 71. And that's already degrees. So we'll put a parentheses and hit equal. 10.57. So the hypotenuse on this one, let's round it up because this is a pretty big number. C is 11 inches. Since this was in a whole number, I'd probably use this. On this one, it did, however, the instructions said to round to the nearest tenth. So 11 would be okay, but they want a little bit more accuracy, so we call this 10.1. Well, the 7 is saying round the 5 up, 10.6 inches. Just slightly bigger than that side. Well, it's pretty steep. So we can find missing sides just like that. Okay. Let's see if we can do another one. Here's one that says, they want us to solve this triangle. That means they want us to find all the missing angles and all the missing sides and all that stuff. So let's draw this. Here's the triangle. 9.6. This, they call this angle A. 28. So we know this has to be angle C. This is your right angle. This would have to be angle B. This is side B, and if you look in the book, they did call this B. This is side A. This is side C. Well, let's find the missing angle. That's usually the easier of the two. These two angles, this is a right angle. That's 90 degrees. Remember, the angles of a triangle add up to 180. If this is already 90, these two angles have to add up to 90. These two angles are going to be 90 plus 90 is 180. So to find angle B, and we're going to designate it with an angle sign, is equal to 90 minus 28. So angle B is equal to, let's see, 8 from 10 is 2, and 2 from 8 is 6. 62 degrees. And of course, you could use your calculator. So let's fill that in on our drawing. I'm going to circle it so that means it was found. So now we know that one. Let's go hunting for side A. Let's see if we can figure out what A is. Well, if we look over here, I always like to label the sides. So looking at this angle, this was our given angle. We want to work with that one because we might have made a mistake on subtracting or something. So A, according to this angle, is going to be the opposite. B is going to be the adjacent. And C is going to be the hypotenuse. To find A, I need a relationship that involves the opposite and the hypotenuse. The sine is equal to the opposite over the hypotenuse. Sine of A, which is 28, is equal to the opposite, A, over the hypotenuse, 9.6. Well, this is an easy one because they're both diagonal. So A is equal to 9.6, and we could put that first times sine 28. When I put this in my calculator, I really don't even have to put the parentheses. I can just do it this way. A is, let's clear this out, 9.6 sine, and the calculator knows automatically I want it to multiply 28. Doesn't know the angle. I have to put that in. So that's 4.5. So now I'm just going to carry it out to one decimal point, unless it tells me different. I don't know if it did or not, but I'm going to write that as 4.5. Okay, now I want to find B. B is the adjacent. B is the adjacent. And I know the hypotenuse. Even though I found this one, it's an approximate answer. So I don't want to use that. I want to use the adjacent and the hypotenuse. What function is that? That's cosine equals adjacent over hypotenuse. So the cosine of 28 equals the adjacent, which is side B, over the hypotenuse, which is 9.6. Well, you're saying, well, I just did that. Yeah, you did it with a sine, but now it's a cosine. It's going to make a difference. B is going to be 9.6 cosine 28 degrees. Okay, so let's put that in. 9.6 cosine 28. See, there's a difference between the two functions, the values. All these values for these things are stored within the computer. What's it equals? 8.47. We're rounded to 8.5. And there we have it. So we found side A, side B. Let's put this in here. So we know side A, side B, we know angle B. We found three missing things: angle B, side A, and of course we probably should put in the measurements, whatever they are. In this case, it was, I didn't read, meters, and side B. Let's try one more. Solve the right triangle. When they say solve the right triangle, they mean solve for everything. Well, here's kind of an interesting one because they do have it all labeled out, sort of. You know, this is our right angle, so this is the hypotenuse. And you could abbreviate, just put an H or something. It depends on what angle we're looking at, so let's not worry about that right now. This is 26.5, and this is 18.2. Okay, so we have our drawing. Now, in this one, we can't really subtract from 90 because we don't know either of the angle. We know all the sides, or most of the sides, but we don't know side C. We don't know this angle here. So I need a relationship that involves, let's work with A first. I'm trying to find this angle A. I need a relationship that involves the opposite and the adjacent. If I'm looking at A, this is the opposite, this is the adjacent. When I look at my little thing, which I lost, right here, tangent, opposite over the adjacent. Tangent is equal to the opposite over the adjacent. So the tangent of 26.5, no, the tangent of this angle, let's call this angle A, is 26. No, it's 18.2. We'll get it right one of these times. Over 26.5. 18.2 over 26.5. So what I'm going to do, I'm going to divide those two. 18.2 divided by 26.45. And that gives me, I'm going to carry this out quite a few places. 0.686. Let's write it down, 79. That'd be pretty close. Okay, now I want to find A. So I'm going to bring this over to the other side. We call that the arctan. Arctan. 0.68679. Whenever we see the word, whenever we bring this to the other side and leave A, capital A, all by itself, that means we're trying to find an angle. When you're trying to find an angle, arctan means second tan. And I have a little funny little thing up there. That means you're looking for an angle, 0.68679, parentheses, equals 34.48. So we rounded off to 34.5 degrees. And there's our angle right here. Okay. Now at this point, we could find angle B. All we've got to do, angle B is going to equal 90 minus 34.5. Of course, you can use your calculator. 90 minus 34.5. 55.5. So now we know angle B. Do we need to find anything else out? No, we already know angle C is 90. So yeah, I guess if you want to write it down. So now we know angle A. Let's designate this with an angle sign. We know angle A. When I brought this over to the other side, I was looking for angle A. 34.5, 55.5 degrees, and 90 degrees. So I know it's not the easiest problem. Okay, now they want to find the hypotenuse. Now, what they did is they used the Pythagorean theorem. I guess we haven't found side C. Personally, what I would do is just use this angle right here, the one we had found. And if we're going to find, if we know angle A, we know the opposite, we need a relationship, opposite and hypotenuse, what would that be? Sine. So the sine of A. So we can write sine 34.5 equals opposite 18.2 over hypotenuse C. Remember what we did before? If we have a missing number here, we interchange. Sine 34.5, and all we got to do is divide. 18 divide sine 34, is that correct? 34.5 equals 31. Does that sound reasonable? Yeah, that sounds reasonable. 31.8. So approximately 31.8. The book used Pythagorean theorem, and they came up with a little bit larger number. Had we had a little bit more accuracy here, using 34.49 or something like that, we might have come a little bit closer. If we round this off, it's going to be approximately 32. So it's pretty close to what they had, see. So let's put that in our drawing. This was 34.5, and this is about 32. Well, I put 31.8. They came up with a slightly different answer, and it could have been in the way we rounded it. These are not exact answers because they're approximations. So, but this would be a lot faster than trying to use the Pythagorean theorem. That's why we like to use the trig ideas. So here we had to use different functions. Here we used the sine opposite over hypotenuse. Here we used a tangent opposite over adjacent. That's why we need to know those trigonometric ratios for the sine, the cosine, and the tangent, because they make a difference. Let me show you one other thing. Say I want the sine of 45. Sine of, not a good angle. Let's say the sine of 30. Sine 30.5. What if I wanted the cosine of 30? Cosine 30.866. See, the sine and the cosine have different numbers. So that's why it's important. Back in the old days, we used to have tables. I was looking for my book here, but I don't see it offhand. Yeah, here it is. We used to use math tables all the time. This book is Standard Math Tables, 18th edition. I don't think they've changed a whole lot. But you can see logarithms, trig tables in here, calculus, integrals. You can see this book has been well used. Before calculators, we used to have to do something like this, tables for trigonometric functions, you know. So all kinds of things we used to have to use. These different formulas, they had all kinds of crazy things. So this is a pretty old book, many, many years old. I think they're up to the 90th edition, you know, kind of dates me a little bit. Okay, anyhow, this particular company, CRC, puts out all kinds of tables, physics tables, tables for electronics, everything. It's you can go to the computer and look them up, and they have all kinds of. It's called the Chemical Rubber Company, kind of a weird name, and that's why they make is books of tables. Okay, so I hope this was useful. Let's give you an idea how to do these problems. Try some, practice some. You know, go through the examples on 661, work through those examples and see what you can do.